All right, so this is about as beastly of a colligative property problem we can give you. So when we have 2.5 grams of an unknown compound dissolved in 50 grams of camphor, Kf, where camphor is 40.0 degrees Celsius per mol, the freezing point of the mixture is determined to be 173.44 degrees Celsius. Pure camphor freezes at 178.40 degrees Celsius. So we want to know the molar mass of this unknown compound. All right, well, what do we all have here? We got a mass of a compound. So our mass of our, in this case, solute is 2.50 grams. And we also have a mass of solvent, which is going to be 50.0 grams. But anytime we're dealing with these freezing point depressions, we know that we're going to deal with molality. And so let's just throw our mass of our solvent into kilograms right away by dividing by 1,000. So that'll give us 0.0500 kilograms. And then this gives us a Kf. We're not sure what we'll do with that yet, but they give it to us, so it's probably important. Of 40.0 degrees Celsius per mol. And then we've got two freezing points. We've got a before and after freezing point of the mixture, and then a freezing point of our pure camphor, just our solvent here. So this is going to give us a delta T, change in our freezing temperature. And it turns out if we do the math here, we subtract the smaller from the bigger, this will give us 4.96 degrees Celsius. All right, well, I got a Kf, and I got a change in temperature of my freezing point. So that just leads me to figure out that I can find out the number of moles. And if I have moles, and I've got the number of grams, I can figure out, well, grams per mole. That can give me my molar mass. All right, so let's figure out how many moles I have. So we're going to use the equation delta Tf is equal to Kf times our mass. I'm sorry, our moles, our molality, I should say, or a little m. So let's solve for our molality by getting Kf out of that side. So our Kf, our delta Tf over our Kf is equal to our molality. And then I'm just going to plug numbers in here. So this is going to give us 4.96 degrees Celsius over our 40.0 degrees Celsius per mol. And if we do the math, this should give us 0.124 mol, which is moles per kilogram. All right, so this is going to give us some number of moles over, well, how many kilograms did I have? I had 0.0500 kilograms. So let's just cross multiply these two to get the number of moles. So moles would be our mass of our solute times our molality. And if I do this, this should give us 0.0062 moles. So once I know how many moles I have, all I need to do then is to figure out how many grams I have. And since molar mass is equal to grams per mole, well, I've got 2.50 grams of my solute, and I have 0.0062 moles of solute. So I'm just going to divide these two, and this should give us right at about 400. I think, yeah, two sig figs here. 403 is what I end up with. But it'll be 403 grams per mole, or 400 grams per mole, depending on your sig figs. So that's how we do this. Bit of a tough problem, but give you everything to find molality. I'm sorry, yeah, molality. And then once we have our molality, we'll solve to find moles. And then once we have moles, we find our molar mass. And that's it.